Good afternoon and welcome. This afternoon we're going to start with a story. I was at the bottom of my first major excavation. 50-foot cut. It's the type of excavation that kind of makes you wonder, does engineering really work? As you're standing up there looking at the W24 by 200s or whatever they were, going, they looked a lot bigger on paper. There was a site visit, and John Wolosik, among other senior engineers from Hayward Baker at the time, show up to the site. And John, if you know him, is a very good storyteller. John comes onto the site and launches into this story. You know, I was at a job site just like this one over here. And that engineer who designed it, God rest his soul, he failed to account for the compression load in the whalers. Your heart starts to sink. And you're like, wait a minute, I think I did that. And this story continues, and by the end of it, I'm not really sure if John said this or if I just imagined it, but by the end, the entire wall had come all the way in. It's a lesson that sticks with you. Fortunately, I learned it the easy way, not the hard way. But since that day, I've never forgotten to design for the compression load in whalers when you've got corner braces inducing them on there. And so with that, we've got 4 presenters who will be with us. They're each going to share some of those stories that stick with you, the ones that we'd never forget. So we're going to start with Mark Plotkin with GEI, a senior engineer with well over 20 years of experience. And then Doug Harden from Schnabel Foundations will be joining us. Also another senior engineer with over 20 years experience. Followed by Damian Sievert, principal at Haley and Aldridge. He informs me that he will not be speaking about the geotechnical engineering that he's such an expert at, but will be sharing other stories. And last but not least, Mike Flynn with Geo-Engineers will be joining us and sharing some of those stories that he will never forget. With that, Mark, come on up.
All right, thanks, Joel. Thanks for having me today. And Damien, it's good to see someone else didn't update their picture. So, greens forward. Okay, so we're going to talk about it sticks with you. So there's nothing worse than getting a phone call, something you've designed has moved more than they think it should. And usually it's moved more than you think it should, not that it's actually failing. But what I've learned over the years is I often get phone calls, and the problem becomes someone's buried a water line, there's water coming in, and you have no clue what's going on. And they become really tough to diagnose. So that's what we're going to talk about. This is a 40-foot tall MSE wall. It was good to hear some other reinforced earth, and I do a lot of reinforced earth design. I've been involved in the projects I'm going to talk about either as the designer and geotechnical engineer, everything from start to finish, or just as a consultant later on. So what happened several years after this wall was built, started seeing cracking behind the wall. And kind of in one of the worst places imaginable, right? You start thinking global stability. The last thing I want to do is see a crack somewhere behind the tails of the grid, wall height back from tails of the grid, and that's what we start seeing. So I'm going, oh no, right? So I knew the design in and out. I lost several nights sleep on this one, what's going on? And sometimes what happens as you're doing this, and these are the inclinometers. I'm going to talk about a few things with these, is when we come into the project, owners get spooked, owners get scared. And you say, well, we need to figure out what's going on here, and the best thing to do, let's put in some inclinometers, let's start the survey monitoring, let's do the work so we understand what's going on. And the owner says, I don't want to pay for that. You work for a consulting firm, you're making the decision, yeah, let's just go put them in because we know it's the right thing to do, and we need to do it. But the owner hires a different firm, and they put in inclinometers a little too shallow. I don't know if you can read this. Those inclinometers went down 50 feet. It's a 40-foot tall wall sitting on soil. So we didn't get into fixity. They weren't really telling us anything. And then if you see the I3A, the one on the right, the really weird thing about that one, it's showing more movement in line with the face of the wall than it was showing up, down, outward. So we're saying, okay, something's going on here. But at this point, I've convinced myself I've screwed the design up. This wall is failing in global stability because we did something wrong. The wall's still standing, in case you're wondering. This, right now, always knock on wood, it still has a happy ending. So you go out and you do real borings. This is a boring through the wall. And you can see bottom of wall, 40 feet, the red's all the fill associated with it. I can't tell you where this is, but we are in the Piedmont geology, and we're getting into Piedmont soils, which are very forgiving. They're a forgiving geology for the most part. And we're into medium dense SM, ML residual soils. I'm going, okay, how am I seeing global movement like this? It just doesn't make sense. And how are we seeing these big translations? An inch and a half of movement in the inclinometers is pretty big. Survey shots were showing we actually had a little over 8 or 9 inches of settlement from start to end of wall construction, which, okay, 40, 50 feet of new fill, not that big of a deal, kind of within the realm of anticipated. So then we see this. This is when we went out to read the inclinometers about a month after they go in. So we did not get rain for a week before this. There's water coming. I think the next slide, if it works. Does everyone see that little bubble? So one of the first things I usually do when I walk up on a project site and there's a moving MSE wall or another wall, the first question is, where's all your irrigation? And have you shut it off? They swore up and down 27 times they've shut the irrigation off, and it was shut off years ago. But I've learned there's a big difference between is your irrigation shut off and have you just turned the switch off to the irrigation. There is a huge difference. This is the 6-inch main feeder line for the irrigation that when we uncovered it, the guys installing it simply butted 2 pieces of PVC pipe together and duct taped them. Yeah, so everyone here understands what's going on. So yeah, I took a deep breath and felt a little bit better once I learned that was going on, and at the same time said, oh crap, we are still in trouble because we probably have actually overloaded these foundation soils. We may or may not have gotten enough deformation, and this is why I think we're okay. We may or may not have gotten enough deformation to get into a residual soil strength. And if you can see this, I think green point, those last 2 points, about 2 to 3 months after the water got shut off, the inclinometers, new inclinometers, these go down to 90 feet, 100 feet, 20 feet into weathered rock, have showed that movement started to slow down and has been arresting. So as of now, it's a happy ending. We think that they've been read post, Piedmont, post Helene, post 2 hurricanes rolling through. We're not necessarily getting surface water infiltrating and causing trouble. But speaking of Helene, here's the next one that storm actually helped us figure out what was going on with the project. So roof leaders. So if you look on the right side or on the left side of that grassed hill or to the right side of the patio, there's another 30 to 40 foot tall MSE wall, segmental block wall. Right, they're common. I think they're common all over the country as they are in my region. And they've been having movement in this patio since it was constructed in 2018. And there have been multiple rounds of inclinometers that constantly show a little bit of ongoing movement. And this is an aerial of the building, inclinometer 2, down towards the bottom. Never really showed much. But the patio has always showed this little bit of ongoing movement. There were some issues with this wall back in 2019, 2020, and they actually had a portion fail. And it was, we heard, causes of failures. This one, the wall was designed great. The contractor decided to build a 2-to-1 slope above the wall without telling anyone. And then the owner decided, let's put some generator pads at the edge of that slope. And then as it started to progressively show movement, it finally just went back in 2020. But we started to see movement after the limits of the repair, and in areas we didn't see anything. Well, middle of September this year, we see a big jump in movement, and you can see that in the green line in the inclinometer. I say a big jump, about 1/4 of an inch, and it's relatively shallow, just in the upper 20 feet. So actually pretty close in the upper portion of the slope. And we're saying, okay, we can take a wait and see approach. I think about 3 days later, they started announcing Helene is coming through. And this is in Fort Mill, South Carolina. So we weren't the eye, but we knew we were going to get a lot of storms. And this was one of the reasons that as we went out to look, we got the inclinometers, we got a call from the property manager, hey, take a look at this. We go out, there's a hole by where that number 1 is. But really weird, the wall looks great. We walk the bottom of the wall, don't see anything new that wasn't there. But that number 4 in the side of a slope, and it's about a 3-to-1, 4-to-1 slope coming down. I think the next slide has some pictures. We just have water coming out the side of the slope. And I don't know why. And again, this is after the first one, so I said, is your irrigation shut off? Yes, it is. Are you sure it's not leaking? Yes, because we had a leak on the other side of the building. My next question was, okay, show me exactly where and show me where you shut the water valve off. So we confirmed that. It wasn't irrigation, but we still don't know what's going on. Hurricane rolls through and I get the call. Hey, we had part of the patio collapse. I'm like, well, I kind of expected that. I've got a big crack on one side and the other going there. Does anyone see something funny in this picture? Yeah, Damien does, yeah. Yeah, the roof leaders, we had asked a few times, where do your roof leaders go? Well, they come down. We haven't been able to find the end, but we're pretty sure they go to the other side of the building. No, they dump out in the ground right above your MSE wall. And believe it or not, here's that same inclinometer. The last 2, we actually didn't see movement post-hurricane, which is really weird. Our preventative measures when that started rolling through was, and sometimes you got to just do it, say, throw as much dirt in that hole as you can for me, put tarps over it, and put plywood over the tarps, and let's cross our fingers. And that's what we did. But we didn't have movement post-Helene, right? And once those roof leaders were cut off, and it was cut off then, the movement arrests. So that's kind of my lessons learned. You're going to get lied to by owners. They're going to tell you we've shut the water off. No, that line doesn't go there. The general contractor is going to do the same thing. Our specialty contractors never lie to us. I've learned that. But that's what's going to happen. So those are kind of the hard lessons. There are good endings on this one, but they aren't always. So thank you. Nope.
Hi, I'm Doug Harden with Schnabel Foundation Company. I'm going to talk about a job that had a not so great ending, but it worked out in the end. Talk about some lessons learned during construction of an earth retention system. This was a project in the south suburbs of Chicago. This is the original design. Temporary earth retention off-wall line. It occurred about 17 years ago. There was one boring on this project that showed a softer clay soil underneath a stiffer crust. All the other borings had stiffer soil. So unfortunately, I discounted the soft clay in the boring during the design as not representative of the actual soil conditions. And when the issues started, did some research on the local geology of the area and found out that it was largely marshland and recovered marshland on this site. So if I had done a little bit more upfront work, that probably would have the soft soils there would have made more sense and stuck out as a potential problem. So lesson number 1 is know the area geology and think about the effects it could have on your earth retention system. In the section there, you can see sort of a stiffer crust at the top and see the significant cut made to the top of the earth retention system. We cut down 10 feet. Basically, we're almost removing that stiff crust for our soldier beam installation bench. And we made a lake, a bathtub. That really affected our installation. We had to work with mats, and it basically, the soils on the site were very sensitive to water, so it softened further the soils that were there. The soft corner, this boring that was soft, it was literally right in that corner, and that was the only area on the whole project that was actually affected. All the other earth retention on the project performed relatively well. This is an excavator that is trying to get mats in place, and it happened to work its way off the mat, so you can tell that leads to a lot of issues with alignment of the beams and installation quality of an earth retention system. And then the photo on the right, we're excavating down past the top of the earth retention system, and you can see by the looks of the clay, I mean, it was soft. The thumb test penetrated easily several inches. So you can probably tell what's going to happen. Get a call one morning. There's a failure scarp up above the wall at the top of the back slope and running through the back slope. You can see that on the right-hand side, and then on the on the left-hand photo, you can kind of see the jog in the wall. So my lesson learned from that, whenever I have soft clays, I try to keep the tieback close to the ground surface. Minimizes the stiff clay crust, stiffer clay crust that's cut out, supporting the toe of the cantilever, because basically we cut the toe out of the cantilever and it was supported by soft soils, so it moved. And then also, I try to pin the top of the earth retention system back close to the ground surface. Sometimes utilities kind of get in the way, but basically the stiffer soil kind of provides a passive strut that kind of pins the earth retention system back, so it actually minimizes earth retention movements when you do cut through the clay crust. So we have a soft clay, modify the design in the corner there for a higher earth retention system, or a higher apparent earth pressure, and then we added a third level of tiebacks to carry the extra load. So we should be good, right? I mean, we got the lateral load in the system. I'm thinking we're pretty good on that. Well, no. The original toe was designed for the 2 tiers of tiebacks. And one thing about wall toes is they're really good at the beginning of the project. And then as you excavate down and add the tiebacks and add these ties were at 30 degrees, so basically half of the tieback load goes into the axial component in the toe, which you're taking away from the toe resistance and adding the axial load from the tiebacks. One thing I've learned on earth retention systems is we test every tie. So we know the ties are good and they're relatively easy to replace, supplement, whatever we need to do. Toes are not easy to replace and supplement. It gets very complicated and expensive. And basically the toe is tested right in the most critical part when you're, cutting down probably pretty close to the bottom of the excavation, and then it decides to let go. So lesson number 3, toe design is critical to earth retention system performance, and you really need to make sure that your toe is good, and it also is highly dependent on the construction method. There used to be a lot of driven piles for earth retention systems. You drove it till you got to a certain blow count, and then you knew your pile was going to basically hold the axial load. Now we've got auger casts and vibratory installation and things that may have, you don't get the same capacity out of different methods of installation. So the soldier beam settles, and then the tieback gets shorter, and then it loses load, and the ground goes, oh, I don't have anything holding me up anymore. So then it tilts toward the excavation. And then everybody is going, oh, your ties are no good. Your earth retention system is moving out, so it must be your ties are, not good. Well, all the tiebacks on this project passed testing. They were actually the best thing on the project in this corner. So, so basically, we talked to the owner and some of the players on the project. They were trying to tell us to put in more ties, and we declined and said, we've got measurements on our beams, the toes are settling, this is what happens. So we decided to, in order to improve the resistance of the soldier beam toes, we installed supplemental soldier beam toe. We actually installed additional soldier beam with a side grip hammer, ran it down the front of the existing piles, which is difficult to do because there's some whales in the way, and I mean it's difficult to retrofit your toes to carry more load. But that's what we did. This arrested the settlement, and basically the movement of the ERS stabilized. Upon the initial movements, the inclinometers, they had inclinometers, they were reading about 4 inches. You could kind of see at the top it tilted out more. You could kind of see the bulge where the soft soil was in the inclinometer, and then in the end, they had moved about 5 inches. The toes have some silt and then kind of a stiff clay. Come to realize that I think we installed the soldier beams originally just with a drill and some lean mix. And I think that the lean mix doesn't have much cement in it. So in fairly decent soils with higher blow counts, lean mix toes are not an issue. But in this soil, with all the water being introduced, creating the bathtub, I think it was running through the lean mix, running through kind of the soil too, and then it was kind of degrading the clay and the silt there, and I think it might have been knife edging the piles through the lean mix and down into the through the lean mix, settling that way. Oops. Here you can see kind of the 3 levels of ties, and then you can see the supplemental soldier beams in front of, kind of inward of the whales, and then there's a header beam on the top that transfers the load from the soldier beam down through that stiffener plate on the top of the transfer beam and down into the supplemental piles installed. Pretty tight work. You can see that by this time we'd strapped the top of the beams together too, trying to keep the movements to a minimum. I find this picture interesting because on On the left, this is one picture. It's kind of spliced together in the middle, but that's the same orientation of they were taken right after each other. On the left side is the part of the earth retention system that wasn't settling and moving. You can see everything's kind of straight and looks fairly lined up. And then you can see on the right, with the soft bench, you can actually see the sheen on the clay. It was like a bulb of soft clay in that corner because it was marshland. So, I mean, you kind of expect that once you figure out it was marshland before. So, one thing that I learned from these are the 3 lessons. And then the last thing I learned was I listen to the field personnel because they're out there every day. They're like your eyes and ears for potential issues. And also when I design a project, I kind of look for areas where there might be issues or conditions that we have to watch out for that may affect the performance or the installation of our earth retention system. And I kind of talk to the field personnel about that so they can kind of keep their eyes on it, all the way from just talking to like the superintendent all the way down to talking to the drillers or, for certain things. So anyway, I appreciate the opportunity, and thank you. Damien's next.
All right, for all you Monty Python fans out there, now for something completely different. It sticks with you. All right, so my name's Damien. I'm a geotechnical engineer. I know some stuff about geotechnical engineering. Most of you are geotechnical engineers. You probably know lots of stuff about geotechnical engineering. This is not going to be a talk about geotechnical engineering. I am not going to show any equations. I'm not going to go through any earth pressure diagrams or theories on downdrag. And though it may kill me just a little bit, I'm not going to talk about or show pictures of cool supportive excavation systems that I've designed and tell you how wonderfully they performed. Not here, not now, not today. Now, if you want to come find me afterwards, we can share all sorts of war stories about building movements and supportive excavation designs gone wrong. But no, today I'm going to talk about icebergs. And not because I have any great affinity to icebergs. I'm going to use them as a bit of a metaphor, all right? So I want you to all think back to, your favorite boss, your favorite mentor, your best leader, and think about what made them that for you. I'm sure they were all fantastic engineers. I'm sure they were very, very smart. But it was probably more how they acted and all that stuff that was below the surface that really was so meaningful to you and into all this. So that's what we're going to focus on. Icebergs have about 90% of them. What make them up is actually below the surface, which you can't see. That's going to be my metaphor for all of us. You see something and you think, all right, I'm going to form opinions about that. I have mental models, and that's where I'm going to base this. So let's take a look at this handsome guy here. I'm going to use myself as an example for most of this, all right? You can laugh at that handsome guy comment if you really want. Short hair, clean shaven, he's got a jacket on, got a collared shirt. You see this guy walking down the street, you probably smile, maybe nod as you walk by. So now take a look at this guy. All right, same guy, a few years older, but we're not going to talk about that. So, longer hair, kind of unkempt beard and mustache. I have no idea what's going on with that hat. But you see this guy walking down a dark alley, and I would take no offense if you crossed the other side of the street, to be honest. Well, that's the same person. That's me. Everything underneath is still the same. But you only see, that 10% right there at the surface. And so the first concept I want to talk about is the essence of that self-management and the concept of minding the gap, all right? If anybody's been to London, ridden on the tube, there's these signs up everywhere, mind the gap. So what is that? Well, that's just telling you, reminding you, hey, I want you to pause for a second. Before you step from that platform onto that train, just take a second, mind that gap, breathe, all right? Don't fall through. Well, that's kind of the essence of self-management, right, is minding that gap. So if you're self-aware, if you understand that and can mind that gap, then you can manage who that person is inside you. So Viktor Frankl was an Austrian. He was a Holocaust survivor. He was a neurologist, a psychologist, and a philosopher. And he has this great quote, or I think is a great quote. Between stimulus and response, there is a space, that gap. And in that space is our power to choose our response. That's minding that gap. And in our response lies our growth and our freedom. So behavioral scientists have done all sorts of studies and determined that, we have about 3 seconds to intervene between our instinctual response, that immediate response, in order to give ourselves the choice for another more cerebral, more intellectual, maybe more intentional response. So I'd like you just to think about yourselves for just a couple minutes, and how do you rate your own self-management? How well can you do this, or do you do this? All right, why do we even need to do this? Well, let's talk a little bit about our authentic self, or the concept of your authentic self. All that stuff that's below, that 90% that's below the surface of the water. So, right, people observe our actions. And those actions, our actions, are really just manifestations, right, of our deeper behaviors and patterns. Well, those deeper behaviors and patterns, we've developed them over a long period of our time, our entire life, just to make sure that our basic motivating needs, what we want, are actually met. Well, all those motivating needs, right, they come from our values, which come from our worldviews and our mental models. For instance, I grew up in rural New Mexico. My worldview, my mental models coming out of there is going to be completely different than coming out of someone coming out of New York City, right? So those mental models are developed in response to our instinctual desires and our fears, and I would venture to say that it's part of our genetic makeup. So this whole concept of nature versus nurture, right? Well, I think it's both. We're all made up of both. But what happens? Well, other people, they just see what's on the surface. They just see that 10%. And they see how we act, and then they interpret our motives, our behaviors, through their own mental models and desires. Not ours, but their own, right? Then they say, hey, I know exactly who that person is, just because of their own being and who they are. So, something to think about a little bit when you're in heated conversations and, a contractor or engineer is chewing you out, or your boss is. Sometimes that feedback can be actually more about them than it is about you. Sometimes it is about you, but that's okay. All right, so what I'm going to do, I'm going to go through a couple tools. These are tools that we use at H&A. There are lots of other tools out there that help us to kind of understand ourselves, because if we understand ourselves, then we can manage ourselves. And we're going to start at the very bottom of this iceberg with our desires and fears. And this tool is called an Enneagram. It was developed over 50 years ago by Riso and Hudson. And really what they do is they divide up everyone self-defines into 9 different types. Now, we don't have nearly enough time to go through and walk through all these different types. So again, I'm going to use myself as an example and tell you what my type is. Well, I'm a 2 with a 3 wing. I am a helper and an achiever. So what does that mean? Well, it means I want to be valued. I want to be loved. It means I say yes a lot. So for instance, how this plays out in reality for me is, Joel gives me a call and says, hey, how would you like to give a talk at GeoTalk? My immediate response is, yes, absolutely, right? Because, well, Joel saw me. He values me. He loves me. I have to do this. Now, if I was practicing what I preached a little bit, I would mind the gap, though, right? I would say, wait a minute. I'm going to take 3 seconds here. And do I have the time to prepare a presentation, come down to Pittsburgh? Do I have anything that anybody wants to hear or that I think I want to tell them? Well, that's yet to be seen, but we'll see at the end. And so that's how that manifests itself for me. All right, so the next thing as we kind of move up the block in these in this iceberg is the concept of management drives, yet another tool. And it takes our desires and fears, and those shape, again, what our values and our worldviews are. And what management drives does is it says we are all a rainbow of colors. Just those colors are arranged in a different order for each of us. And how much that color means or how much our worldviews are shaped by that color depends upon also just who we are internally. But they're important, you know, like diversity in all groups is very, very important. So it's good to have a variety of different colors, right? And now all these drives can be positively or negatively expressed in different situations. Again, that concept of minding the gap. You have to understand, all right, here's how I'm going to respond to that. Is that an appropriate response right now? And then, you know, no one drive, no one index, no Enneagram type is better than all the other ones. So again, I'll use myself as an example. I don't expect you to read any of this. There's a lot of colors, a lot of symbols, has a lot of different meaning. But really what I want you to focus on is that upper left. So my management drives are orange and then green. And what does that mean for me? Well, according to management drives, it means I'm ambitious and focused on achieving goals. That's that orange. And then how do I do that? Well, I do that with other people. I like teams. I like to work with other people. That's my green portion of it. But the other very cool thing about management drives and these other tools is that it gives you a whole long list of potential pitfalls. My wife and kids are very, very fond of pointing out all my pitfalls. So what does that mean? Well, under pressure, Damien, it says, you know, allows fads to take center stage. Well, what does that mean? How does that play out? Well, you know, I refer to this a little bit as the squirrel effect for me. So I'm working on a project, things are getting very tense, whatever tool we're using isn't working out. Okay, we got to drop that tool and go pick up that new shiny object. Oh wait, no, we got to use this one over here. If I, you know, again, practice what I preach, I'd mind the gap just a little bit and say, all right, well, hold on. Why isn't this tool working? Why is it that this new tool I think might be out there is the right tool to use? So again, it's just all about me understanding myself and being able to mind that gap. So the last tool we'll talk about very briefly is something called the predictive index. And it measures kind of at the top of that, what's just hiding below the surface, our motivating needs and behaviors. And this measures predominantly 4 main areas: your dominance, your extroversion, your patience, and your formality. And again, I'll show you mine here. And what you do in order to do this predictive index test is that you basically look at a whole bunch of words and you circle the ones that you think embody you. And they've actually translated this into 50 different languages, and over, millions of people have taken this. So there's a lot of information that is behind it. And then what it does is it says, all right, well, how do you as an individual compare to the average of everyone else that has taken this test? And there's actually 5 standard deviations that it will separate you from. So these are mine. So I'll just point out a couple real quickly. So if I look at the dominance, I am 2 standard deviations below on the dominant side of things. So what does that mean? Well, it means since I'm low scoring that I'm typically agreeable, I'm cooperative, I'm accommodating. Hence, going back to the Enneagram, I like to say yes. So on the other side of things, if we look at my patience level, I'm almost 2 standard deviations to the right from a patience perspective, right? So that means that, I tend to be patient, consistent, deliberate. But again, one of the pitfalls there is that sometimes I don't have that sense of urgency. So some situations call for that sense of urgency. And I just need to be aware from myself that I may not always have that same sense of urgency or the sense of urgency that others have. All right, so I'm sure there are some of you, maybe many of you, that are sitting there saying, oh my God, this is all BS. No tool can define who I am. And I agree. There is no personality instrument that can adequately capture who we are as individuals. But again, they're just tools. Tools designed to measure kind of very specific aspects. So on the right, I just put together a whole bunch of words that, some of what make up the complete self. These tools only get at a few of them. And really just meant to show you how you engage with the world, how others engage with you. For instance, I have my PI, posted outside my office door so people can understand a little bit of who I am and where I'm coming from. But use these tools cautiously. There's a lot of them out there. They have varying degrees of, statistical validity. I personally think the ones that I showed, not that I have any stock in any of those companies, are pretty good tools. We've used them for quite a bit, very successfully. But, with everything, with all tools, use them with care. And, it takes time to use these tools. You can go out, download one of them online, take the test yourself. But like with that management drives, you get a whole bunch of information back. So you got to just really take care and not misinterpret. It's always good to have someone that is pretty experienced with them to explain it to you. And then the other thing I wanted to mention is that, you can act out of your type. Once again, the type doesn't define you. You're defining that type. If you really are self-aware, if you really are understanding, self-management, you can say, hey, wait a minute, I'm going to pause, and the way I want to, the way that my instincts tell me is how I'm going to act in this situation, that might not be the right thing to do. And I can change how I do that. I can do that intentionally. So I will end there, and it sticks with you, right? That's the theme here. And so throughout my career, what really has stuck with me is the concept of minding that gap. Just taking those extra couple seconds to pause and breathe and just think a little bit about, all right, is this response the right one in this situation? Regardless that that's my first instinct in what I want to do. Mike, you got 17 minutes. All right.
All right, so I'm going to close this out. And in line with everybody that's spoken here so far, I want to talk about the things that stick with you. A little bit differently, I'm not thinking necessarily about something that went poorly or went well, but just the moments that really stick with you. And for me, it's generally when we're dealing with something when it's in construction. For most of the young staff that work with me, I often tell them that their favorite project is not going to be their favorite project when they're working on it in that moment, particularly when it's getting built. In fact, many times, it's going to be their least favorite project. It's going to come with stress. It's going to come with challenges. It's going to come with questions. And you're going to have to defend what you're doing. And ultimately, when it's all over, you're going to turn that into your favorite project. But the biggest design challenges don't always occur in that normal design process when we started the project. Oftentimes, they happen in construction. The challenges may seem small or meaningless, less meaningful after the fact, but they often occur when the project is hinging on it the most. And that's ultimately, we do to these great, challenging projects, it takes a lot of our time, but it's that quick call, that small detail that ultimately puts us in the most stressful position. So before I sort of get into some examples of that, I figured I'd at least sort of talk through the typical design process and how that changes once we're in construction. Now, this isn't meant for every job. It's not, the whole process, but in general, every project sort of goes through some sort of life similar to this. There's a pre-bid. We're going after the project. And a lot of us know that while we'd like to say that what we bid is what we're going to build, that's not always the case. It just has to be the right weight, the right cost. It can't be so much that we don't win the job. It can't be so little that we can't build it once we win the job. And so let's presume that we get the reward and we're getting into work. Usually these jobs are going to start with a kickoff meeting. We're going to get the team together and we're going to talk about strategies, what we learned in the bid, how we're going to approach the job, the challenges that we see in the documents, the soil conditions, the process, the approach, the construction techniques that fit our team. And we're going to use those tools and, maybe we had an idea in bid, but we're going to carve it in stone for the design. And we now have a team that can start developing a design. We'll have an engineer, project engineer, or a team of project engineers developing calculations and drawings and getting what's on paper, what's in the calcs and the analyses onto drawings. And there's going to be some iterations and back and forth, and we want to ultimately make sure that the numbers check out. There's going to be a review process. Not necessarily like, is this number right? But is what we showed in our analyses making it to the drawings? Is what we're showing in the drawings going to make it out into the field? And is what we're planning to do in the field actually constructible, right? And after that, hopefully, we've got a stamp submittal that's going to go in. Generally, we'll have a review with the client. Now, hopefully that's going on sort of in the middle of all this, but they're still going to have some input to do. And once that's together, we're going to submit it to an owner. Now, I know, when I put a submittal in, it's approved on the first try, every time. And even if I get an approved as noted, it usually says like, hey, Mike, this is great. Nobody else would have thought about it this way. But some of you have to respond to comments. I get it. And finally, when you can get through and resolve that process, we can actually go into construction. Now, once you go to construction, the process changes totally. You can usually starts with a call that establishes the problem, and then the next piece is developing the design, getting it reviewed, getting it built, all happen at the same time. For me, there's often times when something's getting built and we're designing it after the fact. And so this is all condensed. The process on the left is all condensed into a single step on the right. Now, for our young engineers, we like to teach them with the process on the left, and it takes years of experience to be able to deal with sort of the situations on the right. At this point, I live on the side on the right. So let's start getting some examples. And when I look at a project like this, I see all sorts of construction activity going around. It looks like a mess. But this is a project that I worked on for years. And when I look at it, I see no less than a dozen designs that I worked on. And there's a lot going on here. That there's cofferdams, there's trestles, there's temporary bridges, there's foundations, there's shoring. I mean, it's very busy. But my eyes ultimately go to a very small detail. Something that, started with a call at 6:45 in the morning. And when you get a call at 6:45 in the morning, you know you're in for it. Said, hey, Mike, I know you shored the control tower. We've got a beam that's in the way. We're going to cut it. I don't think it has anything to do with your design. You don't have to worry about it. We just wanted to make sure that you knew about it. Right. Like, all right, what beam? What are we talking about? Oh, I'll send you a picture. A picture comes with a circle in red. This one is like, no. We shored the other side. Like, if you take that down, this control tower is going in the water. Well, the guys are standing here. They're getting ready to cut it. You got to tell me how to support this. Now, this happened in April 2020. For those that sort of remember, April 2020, most of us, not everybody, are locked in our homes. My wife and I are trying to figure out how to handle jobs that are taking us more than 40 hours a week, right? We're also handling the stay-at-home daycare with my 1- and 3-year-old. Construction doesn't care if you've got another submittal to do. It doesn't care if you're on vacation. It doesn't care if your kids are sick. These things happen, and people turn to you and they're saying, we're waiting on you. And so in that moment, it doesn't care that I told my wife, don't worry, I got the kids this morning. And that changed very, very quickly. So I look at that first picture and I see this, just a couple angles bolted to the back of a concrete, some wire cables that go to the beam, something that was only supposed to be there for 5 days and then ended up staying there for more than 6 months. But it was a challenge, it was a solution. It's a really small detail in the construction, but it's the moment of the job that sort of sticks with you. And anytime you go out to that site, that's where my eyes go, because there is a story to it. A similar project. This is 42nd Street Station in New York, Times Square shuttle. A very political job that had a pretty hard deadline. The type of deadline that's not about liquidated damages. I mean, it had LDs, but the deadline was something like the governor and the mayor are watching, and if you miss this deadline, you will not work in the city again. That type of deadline, right? It was very political that the station was shut down for a period, and so there was no missing the schedule. And the job had been in planning for years before I ever got involved. And the whole point in the project was to bring it up to ADA compliance. And so there was load transfers and new foundations and changing of beams. But ultimately, there was this small little piece that we get a call on at Friday at 3:30. Of course, that's the other time that these things happen. And it's weeks before the station's ready to open. And after all the years of planning, after all the months of construction, we get the call and they say, hey, you know how the track and the slab had settled, and we wanted to build a new slab to flatten out that dip so the trains moved a little bit better. Well, we all sort of forgot to take a look at the roof and see if that settled as well. And we did all these repairs and everything's looking great, except the train doesn't fit any longer. The pressure's on, right? The solution is simple. It's just some angles welded to the webs and cut the flanges, but the pressure's on to get an answer quick because the deadline is approaching. And they don't care that it's Friday at 3:30. They need it done. Now, you go into Times Square shuttle, thousands of people go in that every day. You can see these beams. I will always look at that and be like, that was a story. That was a big part of this project. It's a really small issue that occurred, but I will always see the thing that the train wasn't going to get through. You know, I'll bring my kids in there, and it's all that project was really stressful. They're like, why does it look so funny, right? They don't care. Neither does any rider that's going on that day. But these are the parts of the project, these really small details that mean a lot to people. This is the project in the Boston area. And this is a microtunnel that got stuck under the MBTA rail line. Now, there was a whole canopy design that we did with Keller that is a presentation in itself. I'm not going to go through that today. But after months of prepping for this microtunnel rescue, we had one more task to do, pull this thing out. Now, there's a senior engineer here, John Rankin, who did a great job designing based on what the contractor told us, how they wanted to approach pulling this out. And we get a call saying, hey, can you just come out? We just want to take a look. Why don't you take a look at what we've done so far? And you get out there, and one of our engineers goes out there, and it's like, they didn't build anything like we showed it on the plans. And we were pulling out with potential loads of about 800 tons. This was 3-inch plates that were warping when they were doing some test pulls. This was not like, oh, we're just going to move it here. Like, the load paths mattered, the eccentricities mattered, the connections mattered. And each time, it was like, well, we just can't put it here, right? It was easy for me to put it on paper, but it was another thing to actually align it and get it where they wanted. So I'll give our engineer, Nick Mazzella, a lot of credit. He spent a lot of nights there, 5 straight days working 24/7, not him, but the team working 24/7, sort of coming up with designs as it was going in. And I say, well, we didn't sleep till it's over. We slept, but that usually came with us handing hand sketches at midnight and saying, build this while we're sleeping, and then waking up at 5 and seeing like, well, that's not what they built, and starting over again. But after 5 days, what we built was nothing like what we originally intended, but it worked, right? After 5 days of continually changing the design and working through the process, they pulled the microtunnel out in 45 minutes. I got a text at 3 a.m., I was sleeping, saying, it's out, yes. And by the time I woke up, the hole was already filled. It was over. It was a really stressful moment in a really challenging project, and it's a part of this project that nobody will ever remember except for the team that was working on it at the time. The whole point of these is I've got hundreds of projects that I've worked on, and all of them have some small design, some detail like this that matter. We put a lot of effort into the process when you're preparing the big design, when you're getting the team prepared, when you're reviewing the design submittals, when you're getting a good quality product. But ultimately, you need to carry that same quality, that same ingenuity, that same responsiveness over to these challenges that may seem insignificant, that may seem really small, but ultimately, there's these moments where the whole team is looking at you saying, when is this going to get done? The job is waiting on you. And for me, those are the things that stick with you. Those are the parts of the job that you'll continue to remember. And that's it. Thank you.